Okay, so here we are. We've got a conical tank. Has a leak so that it's losing 5 cubic meters of water per hour. The tank has an upper diameter of 12 meters and a depth of 12 meters. So how fast is the surface area of the water changing when the depth is 6 meters? So we're dealing with volume of a cone. Volume is equal to 1/3 pi r squared h. Now, in the case of this problem right here, my radius is always going to be half of my height. So 2r is going to equal to h. So in the place of h right here in this problem, I'm going to plug 2r into its place. Okay, so from here, let's keep going. We get that the volume is equal to, this is going to be 2/3 pi r cubed. And now we got it in terms of one variable. If I had taken the derivative straight from this original problem, I would have needed to use the product rule, and I would have had a very interesting first term. 1/3 pi r squared would have been my first term, and h would have been my second term. So taking that derivative would have been a little bit more involved. But now we're ready to take the derivative here. So my volume, dV dt, the rate of change of my volume, I should say, is equal to 2 pi r squared dr dt. Because the 3's cancel out, right? Okay. So dV dt is 5, right? But because it's leaking water, I'm going to call it -5. Now, the negative's just for mathematical purposes. When I get around to solving the problem out, I'm going to have to take in the wording of the problem to know whether or not I need a negative or a positive in it. Okay, so I've got 2 pi. Now, what is the radius that I'm interested in? Well, the height that I'm interested in, which would be the depth of the water would be the height. So the height would be 6 at this case. So what would my radius be at this point? 3. Remember, 2r is h, so it's 3. So it's going to be times 3 squared, and then we get dr dt. So this is 9 and 2 is 18, so I get -5 over 18 pi equals dr dt. Are we okay to keep going?
Yes, sir.
All right. Now I know my rate of change of my radius. So now I can go about figuring out the rate of change. And most problems we do, we're going to stop here. We're either going to find the rate of change of the radius or the rate of change of the height. But I wanted to go one step further in this problem. I wanted to discuss the entire surface area. This is sign language for surface area. It's also wax on, wax off. I'm going before I get lame. All right, dA dt is equal to 2 pi. What's my radius here? 3. And dr dt in this case is over 18 pi. Okay. Now, the 2 and the 3 becomes 6. So, and my pi's cancel out. So I'm just left with dA dt equals -5 over 3. And now it's talking about surface area. So it's going to be in terms of square meters per hour. This right here, -5/18, would have been just meters per hour. So that is the solution for that particular conical tank problem.